So for number 9, suppose S and T are mutually exclusive events. Find the probability of S or T. So the probability of event S is 36% and the probability of T is 20%. So when we see the word or in these probabilities, we need to think, what mathematical statement does that transfer to? Well, or translates to, is it multiply? No. Is it add? Yes. So the word or means we're going to add them. Okay? So we're going to add the 36% plus the 20%. And we get a 56%. And that is our answer. So let me back up to the last problem, number 8. We have the word and. When it's and, we multiply. And I told everybody to think of multipland, like multiply land, multipland, multiply the and. And then I thought of the word ord for add the word for or. Okay, add, ord. So we've got multipland, multiply the and ord for add the or. Our next probability problem says a jar contains, oh, and here it is. Let me unveil our jar here. It contains 7 blue cubes. There's my 7 blue. 6 blue spheres, right there. 2 green cubes, right there. And 7 green spheres, right there. If you select an object at random, what's the probability that the object is going to be green or a cube? Well, if we were to cover up our eyes and just pick one at random, they want to know what is the possibility that that's going to be green or a cube. So we have to get what is our desired outcome over our total possibilities of outcome. So let's get our total of all the objects that we're adding here, and it comes to 22. We have 22 objects to pick from, and out of those 22, we're really wanting our desired outcome to be either green or a cube. Well, how many are green? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 green elements. And now how many things are a cube? All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cubes. Now we need to subtract the things that got doubled up on, right? And that would be the things that are green and cube. So the green and the cube, we actually counted twice. So we need to take 2 of those out because each element only needs to be counted once. So you add all your greens, you add all your cubes, and you take away the things that are green and cube because we doubled on those. Now, when you finish, then you've got 18 minus 2, which is 16 over 22, and we'll simplify that to 8/11. And that is our chances of picking a green or a cube. Number 11 says, each person in a group of students was identified by year and asked when he or she preferred taking classes, in the morning, the afternoon, or evening. The results are shown in the table. Find the probability that the student preferred morning classes given that he or she is a junior. Round to the nearest thousandth. So what they're asking is who prefers morning classes given he or she is a junior. So that means out of all the juniors, how many preferred the morning classes? What's the ratio there? So all the juniors, let's add that up, all the juniors, given that they're all juniors, we have 18 plus 17 plus 11. Well, that's going to be 46. So we've got 46 total juniors. And out of those 46 juniors, 18 of those had morning classes. So the probability would be 18 and 46. It tells us to round to the nearest thousandth. That is 3 decimal places. So when we do that, we get 0.333. Oh, excuse me. That's wrong. You get 0.391. And that's our answer. 3 decimal places. Okay, and our last problem today says, on St. Patrick's Day, you took note of who was coming into your restaurant wearing green. What's the probability that someone was wearing green, given that the customer is female? So the given that the customer is female, that's like saying out of all the female customers, what percentage was wearing green? So out of all the female customers, we have 25 plus 57. That's going to equal 82 total female customers. So out of those 82, which ones were wearing green? So 25. We had a 25 out of 82% chance. Okay, and again it says to round to 3 decimal places, so that gives us approximately 0.305. And that concludes our study guide. Thank you for watching.